I'm going to talk about Descartes and his rule of signs. We're at 11.5a. If you've missed any of the previous 10 videos for this chapter 11, you can click in the description and watch them. Rene Descartes lived from 1596 to 1650, and he was a French philosopher and mathematician. Did you know he was also good at sword fighting? He was a great swordsman, and he's kind of credited with analytic geometry. In the Cartesian coordinate system, the x and y coordinate plane we use is named for him. We could use Descartes' rule of signs to find the number of positive roots of a polynomial. The number of positive real roots of a polynomial arranged in descending order can be found using this rule of signs. And the rule uses the number of variations of sign, the number of changes of sign, which is a number of times successive real coefficients have different signs. I'll show you. So take a look at this first polynomial for p of x. We've got a 2x to the 6 minus 3x squared plus x plus 4. We're going to start with the plus sign in the very front here. So you have to remember there's a plus sign there. Now, you won't see it written, but it's there, right? So we're starting with a positive. So it changes to a negative, then it changes to a positive, and then it stays positive. So we have two variations, two changes. That one's not included because it didn't change from the sign before it. It stayed as a plus, see? So it changed to a negative, then it changed to a positive, and it stayed there. So we have two variations of sign, all right? Let's try this one. We're starting with a positive, aren't we? It changed to a negative, positive, negative, positive. There's four variations. Let's try this one. Now there's 6 variations. We have an f of x. This is positive, so it changed to a negative. That's 1, 2, 3, 4. It stayed the same, but then it changed. That's 5, and then 6. So see how we skipped this one because it was the same? But we have 6 variations. So Descartes' rule of signs says the number of positive real roots of a polynomial p of x, or f of x, or y, with real coefficients is the same as the number of variations of sign of p of x, or f of x or y, or less than the number of the variations of sign of that p of x by a positive even integer, which means if it's not the same number as the number of variations, it's some number less by a multiple of 2. Take a look at this one. Now we've got the f of x equals, and this starts with a negative. So our first variation is when it turns positive, then it does negative, positive. So we have 3 variations. So it's really important to pay attention what that first sign is, okay? Because the second sign, the second term is going to tell you whether it changed or not, all right? Or the third or whatever, all right? So we can determine the number of positive real roots of this polynomial. There's 2 variations of sign, so there's 2 positive real roots, or 0. So this was a positive, it became negative, or positive. So we have 2 variations of sign. That means that the number of positive real roots must either be a 2 or a 0 because a negative number of roots has no meaning. So it can't be like a negative 2 or something, all right? So it's a 2 or a 0 because if it's not a 2, then it's some number less by a multiple of 2. So we'd have to do a minus 2, all right? And that would give us that 0. I'll keep explaining. So here we have 4 variations. We started with a positive, and we got 1, 2, 3, 4 variations. So the number of positive real roots is 4. And if it's not 4, it's going to be a 4 minus a 2 or a 4 minus a 4, which would make it a 4, 2, or a 0. All right? I'll show you. Keep watching. Now look at this one. We started positive and then went negative, negative. So there's 1 variation. There's 1 positive real root. Probably a negative 1 in there, but we know there's 1 positive 1, okay? Because we're just counting positives right now. Look at this one. There's 5 variations. Now, because there's 5 variations, it started positive, and then it went change, 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 change. So the number of positive real roots is either going to be a 5, or a 5 minus a 2, or a 5 minus a 4, see? So that's going to make it a 5, 3, or 1. So this doesn't have to be an even number. I don't want you to get confused about that, all right? It's how much you're subtracting that's going to be an even number, all right? So if it's not the same as the number of variations, it's some number less by a multiple of 2, okay? So it's going to be less by a multiple of 2, 2, 4, 6, whatever, all right? Look at this one. There's no variations. We got a positive, and a positive. So there's no positive real roots in that one. All right? Now, Appropriately, our next video is Descartes' rule of signs and negative real roots. So we're going to talk about what happens when we have negative real roots, okay? There's going to be links to those previous 10 videos. Hopefully they'll help you. And I'm going to add this to the Algebra 2 playlist. And I hope I explained this well. I hope you're doing well. I added PayPal and a link to it on my homepage in case you want to help me out via PayPal. I really appreciate those who are supporting me. I love you. I couldn't do this without you. And if you would like to also help support my mission of bringing math to the corners of the world, you can check out my homepage, and there's a link in this description. All right? You can either do Patreon, PayPal, or even YouTube fan funding. Bye.